Hi guys, and maybe let's start discussion with Ryan's proposal.
Yeah, I mean, so I can go through it. I basically tried to kind of summarize the FHIR path to SQL translation that I showed briefly, I think a couple weeks ago in this space, and put it on a GitHub issue. It's in the Zulip. We can ping it to the chat if anyone hasn't seen it. But basically all that's in there is just kind of like a summary of what we had tried to express before. Just kind of explore if the appeal of this pattern, if it makes sense, and that sort of thing. It's not supposed to be, it's not an exhaustive treatment of the options or the implementation at this point, but it's more of a start of a discussion, kind of get initial thoughts and that we can evolve from there. Yeah, so I mean, I can go over that quickly if it's worthwhile, or we chat about any specific questions that might come up.
Yeah, let's maybe do some overview and then.
Okay, cool. Yeah, so hopefully you all can see this. But yeah, it's up in the GitHub, and I'll ping the actually I'll just ping the link to the chat here as well for anyone who wants to just click on it and browse themselves. Yeah, so basically, okay, so just trying to summarize, and so I wanted to take maybe as we go through this, so take something of a principled approach as much as we can, to where we kind of like start with some set of reasonable requirements, and then we can evaluate this and other options as we go throughout that. So this is super speculative, and my opinion is like, let's not. We definitely don't put too much weight on any of these. But thinking about through some requirements that we could consider for this is one, just something that's portable between databases and unambiguous. And I think that's a given for any spec. I kind of leaning into like the level 0 or level 1, if that's the terminology we're using. I think Dan coined those terms, and I'm running with it. So I will. Definitely the model of building on like an underlying representation, which could either be JSON in a Postgres database, or it could be a columnar and an Apache Spark store, or whatever you want. But yeah, I think those patterns make sense, and so I still think that independent of this, there's still like a collection of enrichments on the level 0 space, like we discussed before. So those threads seem fairly independent. And so I think that one thing that for a flattened view definition that I think will be a pretty important requirement is some navigation of selecting nested or repeated fields based on values. Now, how expressive we want to get there I would imagine we could keep this really small. Add only if there's a compelling use case. But I just kind of using the use cases of like, hey, can we create a table of home addresses, and can we create a table of systolic and diastolic blood pressures? I mean, if we're expressive enough to do those two things, we're expressive enough to hit most of the analytic cases I can think of. But if we find more, we might need to expand some of the checks there. What this one is going to be more complicated, and maybe it's worth kind of discussing whether we even want to include it here, or if we may have it like an option or something that's used downstream. It is pretty convenient to be able to do some checks on value sets, whether we include that in the flattened FHIR definition or not. I think we should discuss. I actually have mixed feelings about that myself. It can be super convenient just to have like a view of like, oh, here's my statin medications, which could be defined by a statin medication value set. And I think that's really nice to have. But at the same time, it does bring in complexity of introducing actually introducing value sets into the system. And also the query to check value set membership in SQL is fairly complicated. At the same time, maybe that's a good reason to include it in this spec, so people don't have to do those complicated value set checks all the time themselves. But yeah, that's one thing I've had mixed feelings about to discuss. Use existing standards whenever possible, and so hopefully that's given. And then one thing is like I kind of like is, and actually this is something I added, but actually I think I have some formatting issues in my post here, so I might need to review this. Actually supporting direct support of exports from data sources, and so yeah, sorry about the formatting here. I'll see if I can edit this and change this and fix this later. But one use case that's come up. Oops. One use case that's been floated is if you have a FHIR service and you have some consumers that are only interested in a subset of the data for analytic workloads, if we were able to define the tabular view in a way that could be understood by the FHIR service, I could understand like, maybe a special operation that would actually create the view itself and export it in like a CSV or whatever format makes sense, or write to a database. That way, we don't have to export the entire FHIR, the full contents of the FHIR service, and create views on top of that. Although I do think that workload is well justified for like more exploratory work and that sort of thing. We've seen both workloads where kind of folks want the whole content of the FHIR service in store, and others where they just kind of want a predefined subset of it that they can easily query. Yeah, so those are the kind of the requirements, and we can chat about those if those make sense, if there's any things I'm missing. Yeah, so I'll pause there for just a second for that, and if there's not any specific items there, I can plow on into like some very speculative examples of how this might look. Oh, I think, yeah, Josh raised his hand there.
Yeah, I think those are super great, and I appreciate your taking the time to write these up. And I agree with everything that is here. The one thing I'm pushed for something that I don't see is getting repeated structures out when you have repeated structures in. Maybe this is already covered, but like if I wanted to make a table of all observation components, a simple table with just, the component code and the value, is there a way to do that kind of nested selection to get multiple rows out from one?
Yeah. Okay, that's a good point. That's actually not something that is quite expressed here. I get that though. Right. If you just want like component value, that sort of thing, or maybe you want like another possible or a similar example that I think I've seen is like, what if you want a table of all addresses, home or otherwise, and so you want to expand a patient into like all the addresses from a patient. So okay, I think that makes sense. Let me open up my little internal notes here and add that to it. Yeah, we should add it to the GitHub discussion as well, but I think that's a good point. I think there's ways that we could do that. We might just have to expand. We'll have to look into the best way to do that. I can imagine like a FHIR path, a sub expression that would create a table that's still FHIR path. But we'll have to figure out how to do that. But thanks for flagging that.
Awesome.
Yeah, so expression integrates subtable. So your example was like a table of all observation components. I like that.
Yeah, or I think Brian mentioned the address one on Zulip too. So they both have the same shape, I think.
Okay, yeah. So I'll make a note of that. Yeah, so we can add that to the let's.
Are you sharing something? Are you sharing something, or because we see only GitHub? So.
Oh no, I'm just sharing GitHub. I was typing over on I have just my notes. I was just jotting that down, so that's why I was looking at my other screen over here.
Mm-hmm. So we need something like a nesting operation, yes, for that.
I can see a couple ways to do that, but I think that I'd get super speculative and probably get myself in trouble if I went too much into that at this point. But yeah, let's follow up on that.
So I don't know. I mean, I guess this could be related or not. But I guess like looking at the address example, which I realize we haven't actually gone through yet. You're taking the first line of the first home address. And I guess in like a real world situation, if there are multiple lines in the address, you probably want them all and want to concat them with like a new line, right? And so I guess I'm like, is the idea that you would take, like if you left off that last first, would it create multiple rows per patient and then you would aggregate them at a later layer, or what would happen?
In that case, yeah, I think what would happen is in these cases, since these are FHIR path expressions, I really want to like stay with the FHIR path semantics. And so if we took the first off of that, then it would basically return, a list of all the lines. And so basically within that specific cell, if you like had a home address, then the way that if all you did is remove the first, that specific cell in your database would be like a repeated field with all the lines in it, which may be okay. At the same time, I guess another option is I know that FHIR path does support like some string append operations, and so maybe it would make sense to get that semantics to actually, if we wanted to add like append to our FHIR path supported operation list to get exactly that, then that could be something we explore as well.
Yeah, I think there's even just like a join where you pass in a delimiter to a collection. It would be pretty reasonable here.
Yeah, that might be something we want to add to our limited subset, because I think that's particularly like this use case, I think is good for an example, but you would never really just want the first line of a multi-line address, because what do you do with that?
I have a question. So if FHIR path returns in a collection, yes, how flat are we? So do we allow to create the array of something? So can we create array of streets, or
so
we only limit ourselves by simple fields, not arrays?
And so I think that's a good question. I'd be inclined to, so I guess so should this output support, so these flattened views support like stuff that still has arrays, I think is that question. Because if we were honoring the FHIR path semantics itself, and let me, like using this example, let's say we we did indeed, wrote it like this. We got just the line. Yeah, and then that would basically produce an output that has an array of strings. And yeah, and so I would be inclined to say if somebody wrote that and ran it, it should work and produce the array of strings. And then if they realize, oh, I really wanted one string, maybe then they can add the append operation to produce only one string. Yeah, but I'm open to discussion on that. I think like one property I just want to, I don't want to redefine semantics of anything because the huge advantage I think of this approach is that we are standing on the shoulders of well-defined FHIR path semantics. But so maybe the question is like, if a FHIR path expression produces multiple values, do we consider an error condition, or do we accept it and include it in the output?
Mhm.
Well,
As well-
and I guess the third option, which I haven't given as much thought of, around this as you certainly. So I'm really curious what you think, Ryan and Nikolai. But like, I mean, the third option would just be to treat it as an unnest, right? And basically like repeat every other field and do it as kind of a cross join unnest. And like, I get that that's maybe not exactly how FHIR path does it, but if we're translating to SQL, maybe that is the equivalent of an array of values. So I don't know if that's something you've considered and dismissed, or if that's something we should think about too.
Yeah. No, we should think about it.
But from
Yeah.
other side, so most of databases support array of primitives, and it may be useful. I mean, because you can collect the collection of codes or something like this, and the array may be intended behavior. So what I see. So
Yeah, that would be my kind of initial, I mean, just my gut feeling in this space, not having exhaustively considered the options, is that as well. Like if you produce an array of strings, since most of these databases do support arrays of primitives now, I think that's probably as a user what I'd want. I mean, I think about expanding to multiple rows. I think that I think we should consider this further. I'd be a little bit worried about surprising behavior, because I think that we really want things to be like the least surprising output, and like expanding to rows might be surprising to folks and lead to bugs. That's like my only reservation there, but I think we need some more diligence on that as well.
Yeah, just to add to this, I was just going to bring up the two examples off the top of my head, which would be codable concepts, where you have a bunch of codings, which you see a lot of times where they'll have all these codings from different systems and different mappings, some from SNOMED or ATC or whatever. So we would definitely need a way to handle all those codable concepts and arrays. And then the second case would be something like the observation.component, where that's an actual structure instead of just a coding, which in theory you could, join as a string, right? Join it as system and code. But the codable concept is something nested where everything is very different. And so I'm not exactly seeing that. When I see the word first all over the place here, that makes me a little nervous that we're not handling all these deeply nested.
Yeah.
Yeah.
So I can put together, some, actually I have some like more concrete examples that I'll add to the thread as but yeah, you're absolutely right. These are just things that I kind of had handy with some quick experiments that clear semantics, and perhaps that don't illustrate all the things in that case. I mean, I can share an example like of like observation components. A lot of times like the queries that we found there would be like in the case of like basically selecting a component using like a where expression and then getting the value from that. So selecting the systolic blood pressure and putting that in one column, and selecting the diastolic and putting it in another column. So that kind of navigates so rather than including like the actual codable concept in the output in that case, at least, it's actually creating first-class columns for systolic and diastolic, which are a bit easier to use. That said, there's certainly use cases in which we want to expand the codable concept, the code values for that sort of thing as well. And so, I think
claims is a good example when we probably need unnesting on these flattened views, because there is no difference between items, yes, in claim, and you will probably need to unnest all of them and create a separate record for each line.
And actually, that's really an interesting kind of example you used, that you would query systolic or diastolic at this view layer, right? Because that, at least maybe that makes sense in the application, but my initial intuition would be that type of query would be at the SQL layer. You'd be doing that on the view. You wouldn't be doing it at this layer before it even gets into the view.
Yeah, and I think it's probably a different I can see different use cases like in models in this. I mean, so like if I'm sitting down at like a notebook and I want to do some analysis of trends of blood pressures, I mean, the data model I want for that is maybe just a table that has systolic and diastolic patterns. At the same time, if I'm trying to build like a more general reusable view for a suite of applications, then yeah, what you described probably makes more sense as well. So I think that we're going to see like a bunch of different, I mean, yeah, we're naturally going to see like a bunch of different usage patterns and like how much we want to honor these. But yeah, I guess what I'm hearing is that we need to make sure that we have a really good pattern for the class of problems you described, where we're extracting like code values and allowing at query time, that analysis there, which yeah, I agree with. So I'll add that to the notes and we'll see if we can find ways to express that as well. This is great, by the way, folks. I really appreciate like the perspective and inputs and use cases through all this. Yeah, well, this is a great exploration for things that from folks that have seen a lot in this field. So I love it.
So you did some implementation, and do you created some grammar for it? So because I think we are talking about some limited subset of FHIR paths, and it would be nice if we can express it as an Antler grammar. So everybody will understand the limitations. Yeah.
So and this is is already out of date based on the discussions we've had in the last 15 minutes. But I mean, I tried to enumerate a few of the things that we would need here. Yeah, we've already probably expanded this list and maybe to like the string append stuff and probably others that we mentioned. Yeah, so I think this is like a very minimal initial proposal, and we could, but sure, some of this we may want to remove, and others we may want to kind of add from there. I think we could turn this into a FHIR path grammar. It's like it basically would be. Actually, I'm not sure if all these functions are defined in the Antler grammar or not. I think that the functions may be checked when it's interpreting the grammar, but I'm not sure. Actually, no, maybe it is in the grammar. But
if we bring the limited set, so we probably can enumerate these functions. So the grammar will check that.
Yeah. Okay, so I mean, we could. I mean, I imagine we could just take the existing FHIR path grammar, make a copy of it, and delete a bunch of stuff, and pretty much get to
you will probably delete the most of FHIR paths. I sent the link in the chat when I played with the grammars, and I tried to do it almost like you described. So, and it is very much smaller than what we have in FHIR. So, and it could be more strict. So.
Nice. Yeah, nice. Yeah, that's kind of like a neat idea of an explicit grammar for the subset that we'd support for this. Yeah, and that way it would. Yeah, I mean, if as tooling evolves that supports it, then Antler does a really nice job of reporting grammatical errors. So if you have a function that's not supported, Antler will tell you, which is pretty nice.
And we already discussed. So you expect that these flattened views only work for the per resource. So we are not talking about joining or getting references.
That's my inclination. If others disagree, we can certainly discuss. But my perspective is I'd rather put all that work on the database and SQL queries. Those are pretty well understood and work quite well. And introducing join semantics in our view definitions basically would mean creating like our entire separate language specification, or it seems like that more.
But you still want to introduce like some filtering expressions like IC constraints?
Yeah, so I think having some constraints would be useful, particularly in the use case. But as long as the constraints are defined by FHIR path expressions, I think they'd be, because it'd be relative. If we can translate these other FHIR path expressions to SQL, we can translate the same expressions and put it in a where clause instead of the select side of the expression. I mean, the main reason for that is like users that might be interested in the view only a subset of data that want to filter on some criteria. So this example I'll run back to is actually, I think I have it in, I have it here. So if you wanted a table of LDL values, for example, and so you can slam that in, like you do some historical trending of that or whatever things you want, that the ability to kind of filter, have a constraint to kind of filter on a specific value set is pretty useful.
I'm just a little bit scared that so if we will try to put all possible criteria in this constraint, it may be quite complicated.
As we are doing with this, we would support, like the only the subset of FHIR path. I think that the one area that it gets involved is like specifically I mean, this sort of the value set checks. And like I said, I mentioned at the top is like, yeah, do we really want to get into this in this, the value set stuff in this views? At the same time, it's kind of nice in a way, because I mean, this like right out of the box lets somebody like sit down and you know, create that view, plug into their analysis and run from there. And the other thing is, and I guess like, but it is a double-edged sword. I mean, like generating the value set SQL is complicated, but at the same time, if it's not done like in this case, then yeah, it does sort of push more complexity into the user of the views. So like, for example, I mean like if your observations, you know, may contain, you know, obviously many times observations will contain code values from many distinct coding systems and be repeated. And so creating navigating that is in a tabular model, I think can get complicated as well. So there's some questions of where we would place that complexity. So I put this here because it's kind of a convenient way, a convenient sort of straw man proposal in this case. But if there's other ways to do it, then we can kick those around too.
I think using the expressive power of FHIR here is good, as long as the data you need for the computation are inside of the resource. At worst, it's sort of a table scan. And if you're materializing the output, like, great, you had an easy way to express what you wanted. It's very general purpose. And it's not like it could have been a lot faster no matter what choices we made.
Yeah, I tend to agree.
Evan is asking, so can we use structure definition to define such views? So it potentially can be quite easy, like logical model we already discussed.
Yeah, and so to be honest, I don't know. If we can, then great, I'm all for it. Don't read too much into this little JSON structure I put in this sort of thing. I'm more focused on the FHIR path and semantics, so I kind of invented a little JSON thing to put around it to kind of put some structure here. But yeah, whether if it's a structure definition, or maybe there's like something like a view maybe there's something more specific to this, like a view definition resource. I think that may be like a follow-on item. I would love to have this expressed in some sort of standard FHIR resource that we could share with communities, whether it's a specific structure definition for this sort of thing, or it's a view definition that has like the column name and the FHIR path expressions for it.
I think if need be, we can always profile the structure definition resource to have some specific stuff about views if we really need to.
Yeah. It
So
looks like we only need one extension, like FHIR path.
yeah, we probably will need some extensions, but okay, I just wanted to make sure that you hadn't exhausted the structure definition resource and then discounted it because it was insufficient. Because if that's the case, then the next thing I would have proposed was, if structure definition is not good enough, we either need to think about what changes we could make to it to make it sufficient for this, because the goal of structure definition is to be able to model essentially anything that is essentially like this. Or if that is way too difficult, then the next step would have been to, let's create a resource for this, right? I'm happy to hear that. That's good.
Yeah, and either. Oh, go ahead.
You first.
Oh yeah, So no, I basically plus one that comment. I agree. If it can be expressed sort of cleanly and intuitively in structure definition, I'm all for putting it in structure definition. If it turns out there's too much sort of baggage, because I mean structure definition is super general, and if that seems too complex, then I think it's reasonable to consider as a new resource to express these things that are sort of tailored to it. I'm open to either one. I do really like the idea of having it defined in a resource, whether it's structure definition or a new one.
If this can be expressed in structure definition, like, sure, we can publish a copy of that so people who really want to consume it in that format can have it. But I wouldn't focus on that as the primary representation. I would focus on whatever's easy and useful for us as the primary representation. And I could imagine a lot of things that I think would be much easier to work with, maintain, and edit than a structured definition. I also don't understand the value of having a FHIR resource for the views as an end game here. Like, this is fundamentally not about, like I can't imagine composing this FHIR resource with other resources in any specific way. And it's really focused on JSON syntax FHIR, which is only a subset of use cases for FHIR anyway. Like, for my purposes, I'd much rather just have like JSON schema that describes the thing and be done with it. It's a pretty nice set of tooling and, easy to work with.
Well, the answer I would give to that would be that, this is supposed to be a FHIR project. So we should be using as much of FHIR as we can to solve the problems that we're trying to solve. If there's a FHIR solution for this, why would we not use it, right? Then we're basically just saying, well, we don't really like FHIR in general.
that's not what I'm saying at all. I mean, like, my perspective would be we want to find tools that are effective for the problems that we're solving. Of course, the main problem we're trying to solve is working with FHIR data. But I don't think the problem we're trying to solve is extending the FHIR specification. Like, that's not part of my problem statement, at least.
But in
No,
future,
that's
it
fair.
may be good to have a resource to define views. So the FHIR, I don't know, systems may expose like discovery what views are defined, yes, and the simple CRUD semantic may be used to define the views, yes, and list them.
This is certainly like a much more theoretical conversation, so I don't know that we need to rat hole on it. I just wanted to get my perspective out.
I'm frankly torn on this. I think everything, Josh, what you described is totally reasonable, and Evan's like the reason I mentioned that I find like some sort of like resource-based model appealing is like it is very speculative, but I could see a path that I think maybe Nikolai alluded a little bit to this as well. Whereas like if you have like some sort of like FHIR service or FHIR server but you needed like a set of you needed it to export like some sort of set of views for the subset of its data. If I could just send it a bunch of structure or a bunch of like view definitions or something like that, say, hey, here's your view definitions. They're FHIR resources, so you know what to do with them. Now here's a custom operation to export those view definitions to some sort of target. So I think that if we were to go deeper into the FHIR server stack, which is much more speculative than it seems appealing. Yeah, but honestly, I said I agree with the sentiment. Like we should try to keep these sort of very, very simple and easy to look at. And that was like the only reservation I had with the structure definition wasn't obvious to me that we could keep it simple and easy to look at in a structure definition. But like I said, all of these sound reasonable to me. I think we need to work through it.
I think Ryan just said a lot of what I was going to say. I think there's maybe some advantage to being able to have these as FHIR resources, just so that if you want to, for example, like do an export from your FHIR server, you can reference a resource that's there, and you can use kind of the FHIR semantics to list them and that kind of thing. Certainly you could have other structures in the FHIR, another API, but just it's a nice way of storing knowledge. But I guess I'm definitely not in favor of structure definition if it's going to add a lot of complexity that we don't need. And so I guess my view would be that we worry about kind of defining the simplest possible thing we can do to get this done, and then look at once we have a structure that we're really happy with, decide if it's in a structure definition, or if we want to create a resource representation, or if we want to just include it as a binary resource as a JSON blob. I guess like I don't have a strong opinion there. I think there is some value in having some way to shove it into a FHIR server so you can reference it when you do like an operation to say generate CSV or something.
Mm-hmm.
But that would be the only reason.
That's a good point. Maybe just like as a working group, we just keep it in a simple, JSON structure. Like here, just keep everything. Then if we feel good about it, then we can figure out how to put it into stronger structure going forward. And I think for all and just as one sort of side item as we work through these, I'm trying to take some notes. I'll try to like create like a list of open questions and include this on that, and we can come back to these open questions follow up as well. But sorry, Nikolai, I might have interrupted you.
I do not see the big difference with structure definition. That will looks a little bit more ugly because the structure definition just set of elements. Yes, here you have a set of columns, so it fit quite well. Yeah, just more to write. The structure definition definitely can be generated from this simple, as Josh said.
The issue with creating a bespoke JSON structure is that we're going to reinvent concepts and a data structure that the structure definition resource has already done, right? So you look at the mission statement of a structure definition resource, I'll paste it in chat, but I mean, basically what it says that it defines is path, cardinality, data type, definitions, default or fixed values, constraints, length limits, and other usage rules, terminology binding, mapping to other specifications. I mean, this is basically what we would have to invent in a custom JSON format. And it feels like wheel reinvention. I
would say we will focus on what we need, and then we can get back to a structure definition.
Well, I mean, with all FHIR, right? Virtually everything in a structure definition has a cardinality of 0 star, right? Like it's you don't have to include every single field in a structure definition. You can use only what you want. And I think if you minified a structure definition and only populated the stuff you cared about, it would be similarly terse. Certainly, it's going to be a little bit more terse than what Ryan's presented here, which is, very nice and neat. Structure definition has a little bit more cruft, but not that much.
But what
I think we should
interesting
explore it.
inference from structure definition that we can introduce kind of inheritance for these views.
I mean, if we wanted to get ultra meta, we could describe the JSON that Ryan is proposing as a view of our structure definition, but I'm fine with modeling this in simple JSON for now to, as we say, model only what we need, make it simple and easy, and then we can look to see where the mappings are to structure definition. And that can be something that I do, or, I know Brian Kaney is interested in this too. So maybe me and Brian just, spend the effort to figure out how to represent this in a structure definition so we can have our little box checked, and people who don't want to use structure definitions can continue to use this JSON representation.
I think
so there's this I was just gonna real quick say that. So there's this JSON that we're talking about. What about the output? Right, so the output's going to be flat probably, or something, but we're going to need types. Is it a date time column, an int column, whatever, all the SQL columns. Do we have that mapped anywhere, or is that kind of just because it's obviously a function of what's returned by FHIR path?
Yeah, I have not formally defined that map. Some are going to be very obvious. Others I think are going to be a little more complicated. There's always the date, the lovely date type with unclear ranges that is always going to be the ugly corner case that we need to figure out. That and most of these are I think of course, since different databases have like slightly different supported types, but in most cases, it's like most data is going to be a string, or actually. One thing that we probably want to cover is like decimal types. We probably want to promote to like the first class decimal types in the database whenever possible. But since different databases support different versions of different types of decimals, then the output may be a little bit database specific. It's I think we can kind of come up with a reasonable definition of those. I'll add it to the open question list that I'm building here. The dates one is I think a more challenging one. What do we do with that?
Would it make sense for that output to be defined as structure definitions so that people can see what the views are, kind of like in a FHIR UI? I don't know if that makes sense or not, but it's, because we want to say, hey, here's your view, here's how you write your queries, what would be a good format for that, or what's the most common way to represent the SQL schemas? Yeah,
let's do experiments. So I think it can be easily expressed with a structure definition. It will look a little bit more ugly. After that, with a bunch of extensions, but
I think there's some value in not worrying about that too much until we decide like what kind of constraints do we need, which functions do we need to include, like how much transformation is there going to be at the FHIR path level. Like I think once we figure out those questions, then like I think it'll be more obvious how to serialize this into either structure definition, FHIR, or JSON, whatever we do. But I feel like it's a little premature because we don't know, like, I think we're still deciding like what kind of constraints we might want to have, how value sets are going to be handled, and all of that will impact kind of what sort of models you can use to represent this.
Yeah.
I'm all for trying these things. Yeah.
Yeah, no, I agree. I think it'll also be easier for us to work through some of those decisions without trying to perform mappings in our heads back and forth between this more abstract structure. So it'll be good for us to start here until things sort of settle out.
Sounds good to me as well. Yeah. So I don't want to imply that we're I think structure definitions make a great deal of sense, but yeah, this is kind of a nice sort of, even if we're viewing this current JSON as like a working pseudo code for convenience now. I think getting the FHIR path semantics correct, the handling some of these sort of unnesting operations that we described, handling the type conversions, those seems like much more more critical problems to show whether this is a viable solution or not. I think
getting this subset of FHIR passes is very important here. So put the restrictions and maybe publish it even as a IG on FHIR pass.
Based on like some like experiments, so as we showed like a couple weeks ago, we've like some experimental code that kind of does this and has been playing with it, and for what it's worth, like this is like the subset that I found useful to do quite a bit. I think we've already added like the string join to the list that we'll need to add there. There will be others as well.
I
Maybe
would
we can remove this
probably
first
add
one.
the square brackets to get specific elements. It may be sometimes useful, like ends of array.
Yeah, we can consider it. I can't think of too many use because every time I want to access like a specific item in a FHIR array, it's usually based on some value or some like a slice discriminator or something like that, like finding the home address, whereas finding like specific offsets in an array. I know that there are examples in which things are ordered with specific meetings, but so we can add it if there's a use case. I didn't include it because I didn't see one right off the bat, but obviously there's I know I'm missing things here.
Yeah, almost all arrays in FHIR do not have meaning in their order, as you say. Like there's a flag in the structure definition that tells you if the array is supposed to have meaning in its order, and there's very few places where we use that.
Yeah, I guess the only other one that is kind of the one I mentioned before, and I don't know how this maps into FHIR path, but I wonder if we want like an explicit unnest kind of function that you could put at the end of a FHIR path expression that would basically, so, you know, for example, in the component use case where you want to kind of have your component, you know, all the component codes and values kind of spread into a single table. If you had some sort of unnest, and I want to draw this out because, you know, it's hard to do this in your head, but I guess I'm wondering if we want some sort of specific, so if you're going to get an array, if you don't put a first at the end, then I wonder if we also want a dot unnest or something. And so that would basically create an actual flat structure.
Or maybe on top level, you can just enumerate by which expression you want to unnest, so that we will
or multiple expressions, right?
Yeah, or
If you have multiple
by one
extensions
unnesting, but yeah, just on the level where constraints living in columns, just say I want to unnest it by this specific name of element or expression.
Because then, especially if you're like coming out of CSVs and want to process it using kind of standard tooling, you know, you would need kind of the full unnest. So if you want to be able to do that in one hop from a definition, we need probably something along those lines.
I think maybe we can work through some use cases. I mean, I think we touched on a couple earlier. Yeah, it's like, what are some, and I think I can encourage everyone to sort of contribute like scenarios to, I mean, maybe on the GitHub discussions, like here's a view I see, or a type of view I'd see, I'd really like to be able to create. And we can kind of do that. I do agree that there is something there. Well, there's certainly things a lot missing here. Some form of like, how do we handle like a nest or flattening of repeated structures is a key piece of that. We'll have to explore. And so I kind of adding like a nest expression, you know, to this makes sense to me. I think it keeps it pretty clean and readable. Maybe it's a little less quote unquote pure because it goes beyond FHIR path. But I think that could be well justified. I mean, we could, and I'm just thinking out loud here, I mean, if we could like add like metadata to the column, like you could have, rather than just having a simple name expression, maybe we flag like this isn't flag columns as like unnested columns or something. But yeah, I don't know. I don't love that.
Maybe just put a unnest expression, and let's maybe allow one unnest expression, because if you do multiple unnesting, yes, so then the semantic is quite strange. So you should multiply it, yes. But if on the top level you can do the FHIR path expression unnest key and FHIR path expression, so you will understand how you want to unnest.
So I'm curious about that, Nikolai. So like, why not do multiple unnests and just kind of do it as kind of a cross join if that's there?
But that sounds strange, like, so yeah, you can do the multiple unnest with a cross join. Is it useful or not? Maybe you can unnest. Yeah, there's some problem with it.
Well, like if you wanted, sorry, yeah, if you wanted to like unnest both, you know, I'm trying to think of two extensions that might have multiple values. So like race is a good one that would have multiple values. And then you also want to nest something else about the patient. Like for each patient, you might want a row for each of their races and for each of their address lines or something. And then later on, you would concat that a certain way in SQL or do something with that. That's a terrible example. There are actual use cases that I can think of, and I'll try to put one or two in the notes. But I guess I have done multiple unnests on resources, and it's been pretty useful. And then kind of aggregated up after that in different ways after filtering. So I guess unless there's a reason not to do it, my inclination would be to do it, but I think it's fair to say bring use cases, and so I'll try to think of some stuff and add it.
Mm-hmm. And this again did bring us to the question: how flattened should be this view? Do we require that after that flattening only primitives, or maybe an array of primitives, or potentially some attribute can be like some nested data structure can be the value of the column? So that's, I think, an important question, because we can do kind of the second view on top of view. Yes.
I guess I think this is something we should work through, but I guess my inclination would be that we probably, if we're going to support like return of arrays or maps as the result of an expression, then I think we should also, I think that we also have to support, it would be nice to also support like full flattening in some way without having to necessarily assume that you're going to load it into something that can handle those primitives or those kind of complex primitives. And so I could see, I guess I'm not set on this, but that's kind of my first thought, at least, is that I can certainly see use cases where you would want a fully flat structure coming out because of what you want to do with it.
Yeah, that's true, but there are a lot of useful scenarios when the semi flattening may work as well.
Totally. Yeah. So I wonder if I think the solution is not always to add more features, but maybe this is a case where we want to be able to support both based on how the expression is written.
Yeah, and I think that maybe like whether a feature is justified would be a function of like, hey, are there real use cases that provide sufficient value? And if we can find the real use case that find value, then yeah, it certainly justifies the added complexity for that sort of thing. Yeah, and I can imagine. Yeah, so I think I do agree that there's something more needed here, some sort of like a flattening to handle it, so flattening and cross join to handle it. Yeah, so but yeah, I think as we kind of enumerate these, then we can figure out how far we want to go in that space. And I do kind of like this. I mean, the suggestion of like an unnest addition to that. That seems fairly clean. But yeah, maybe if we enumerate, so maybe like I'm just thinking out loud here, but if we kind of enumerate some of these use cases, and then we can kick around like variations of expressing them, like as we go forward. Yeah, hopefully converge on something that seems still reasonably simple, but expressive enough to be useful. Yeah, I had a few notes just kind of adding like some quick experimentation of like the recursive translation. I don't know if this is super useful or not. Yeah, I think, well, maybe I will touch on a couple of the challenging pieces. Like, well, one is yeah, I guess like, well, the dates and extracting like the identifiers in a join convenient way. So I think there's some open areas there. So in some like experiments, I kind of cheated a little bit and added a fake function that doesn't exist in FHIR just to get like the raw ID out from that. But maybe I think some of these will be contingent upon what we want to do with like the level 0 stuff. I mean, if we're going to extract IDs and hash them, we should at that point we should maybe reflect that in this as well, so we can easily join from there. So yeah, I think like the join IDs is a question, and then in terms of the implementation, and I guess Nikolai, since you're experimenting with this a little bit, you might not run it into it so much with the JSON model, but when translating it directly to SQLs, like I found that we needed to know the actual, it was very important to know the cardinality of each level of the expression, so we know whether to generate an unnest or just access a field directly. And so that added, that was actually like one of the bigger areas. And right now, frankly, our code is like totally in the midst of refactoring because it's totally experimental stuff. So it's pretty much a mess right now. But yeah, that added like a fair amount of complexity, just needing to, for each FHIR path expression, to know like, hey, what are we looking at? I mean, so we had to like look at the structure definition to know the cardinality of the field, and then some FHIR path expressions always only return one. So and be able to tap into that knowledge as well. So I think that was one of the bigger sources of complexity in terms of the SQL generation. Otherwise, beyond that, it's like, not to oversimplify it, but a lot of it was kind of like, oh, we saw, here's like this FHIR path expression, and we could generate, SQL snippet that roughly maps to it, but we did need to incorporate like the cardinality stuff there.
Now, what's good, it can be done in compile time. So in compile time, you probably can use metadata like FHIR metadata too.
That's absolutely right. It just makes the logic at compile time a bit more complex. But at runtime, it's just it's just SQL.
And then missed the last meeting, so I proposed like maybe let's consider use UUID data type for all the IDs and references and resource IDs, because it may save the space on disk. Yeah, this is the first option if the database support native UUID. So, and if you compare the size of string of UUID and UUID, it will be twice less. Okay, and as well, the UUID version 5, which almost doing what you wanted then, like hashing by source. It's a part of the standard.
A question on that. I guess, like, what's the advantage of specifying that versus letting each implementation kind of decide how to structure the IDs? Like, do we care if it's a string or a UUID from, I guess, either the flattening perspective or subsequent querying? Like, could that just be an implementation detail, or is there a reason to like kind of put that in the spec?
Yeah, I have two reasons to think about this. Yeah, the first is the performance and size reason, and the second is to force people to use unique IDs, which is kind of as well good. So if we because I can imagine scenarios when you aggregate from different sources, yes, or you query multiple databases. So if you do not put this restriction on ID, I think the FHIR can consider like saying that all IDs should be UIDs. But so that's reasons. I understand that it's probably too much to constrain. The nice thing that UUID version 5, so you can hash any string into UUID. It's not reversible, but it's in one direction. It's reproducible. Yes, so it's a hash. So that may work.
Yeah.
So then we will try to guarantee that the all IDs are uniques, and that we can.
We could maybe recommend that.
Yeah, it could be a recommendation.
Use globally unique IDs and suggest a strategy without requiring it.
Yeah, that's nice. Yeah.
I mean, I think documenting an assumption that the IDs are unique, like, is there, like, if we're not going to be including the resource types in the IDs for joins, we kind of have to assume that they're unique across the whatever database is being queried, right?
Across the source, yes, but if you consider the use case when you aggregate from different sources, so ideally you just want to merge these databases and everything works, yeah. So let's say
so you'd have the extra step of like
yes.
uniquifying the IDs on import or something if they're not already UUID 5s, is what you're saying?
Yeah, I said that any string can be translated to UID 5, and UID 5 has a notion of namespace, and it's the same what you try to introduce with the source idea. Yes, so when you're hashing source plus the ID, so essentially, it just brings details to your algorithm, like, because inside of UID version 5, I think SHA-1 algorithm, so SHA. Nice to do it like recommendation.
I agree with the I mean, I think we certainly have, I mean, some requirements, but I mean, perhaps like these things, these identifiers are, comparable and globally unique, and we recommend UUID 5 for some of those reasons, and maybe stop short, a little bit short of a strict requirement, because like not all databases have a native UUID type. But yeah, we certainly, like, the requirement should be the hard properties. I mean, if we want global uniqueness, then yeah, we should definitely state that.
And for dates, the same, like, so we are talking about kind of creating from, let's say, so we have a year, yes, and the type of the column is date time, and that's always a problem with the databases and native types, yes, because usually you have to year, months, and day, yes, or with the minutes and the seconds. So and I see that the first normalization can be bring this like partial dates to the ANSI dates or ISO dates, yes, something like this, which most databases understand, like probably ANSI SQL specify how the dates and date times should be encoded. And then the next step could be introduce the periods, yes, with the start and end. It's still there's still a lot of question. If in a birth date of the patient we have it just year, how to work with it, yeah. So we can just make it like 1st January, yes, of this year. So databases will understand it. But then we kind of losing some information, yeah? Or should we convert it into the everything to period? So, and just if it's specific date, it will have just two same timestamps, yes, which mean point in time.
I think I mentioned on one of the calls, and we don't necessarily have to go this route, but what I've done in the past is converted every date into, as you say, a period, but also included the original precision level as another kind of element. I was doing custom stuff, so I didn't have to like fit into the FHIR period, but I created a date time, a timestamp for start and timestamp for end. So a year would be from the January 1st at at 12:01 a.m. until December 31st at 11:59, and down to the millisecond. And then the precision would be Y. And so if anybody ever wanted to it kind of gives the querier the option of kind of deciding what level of precision they can live with, but still being able to query for people like born after a particular timestamp. So that's one option to kind of do either at the ETL stage when you're loading, or load the raw FHIR and then do it in database transform to that. But then we wouldn't have to deal with it at the level of the flattening, which would be nice because you can just assume that every date time is a range with a precision.
Yeah, I struggle with this one, honestly. In a general model where you know nothing about like the underlying data, like something like that almost seems necessary, because you could get just a year, or you get a specific date time, and you need to have correct logic in both. At the same time, in practice, like many resources, even though it's a date, will like just the nature of the source system, the data is actually a specific date, and we know it, and it's convenient if for example, if we know in this particular FHIR service, this particular source of data, birth dates are always full dates. It'd be nice just to be able to propagate those as full dates, because then that plugs much more cleanly into all your analytic tools. And so I wonder if we can toy with the idea of like, as we define these tabular views, like is there some sort of assertion, hey, we expect full dates for this field to create this view, and and have like some way of handling that if it's malformed in the mechanism. But I'm mostly thinking out loud at that point. But I think that a lot of since maybe if make this explicit, but like one of our goals is to make FHIR data really easy to use by folks that are comfortable using SQL, and that they're gonna like, why? All my data has full dates, and yet you're making me do this range-based comparison, even though that's not the case. And so I feel like navigating that in practice is going to be something we need to explore as well. But I think we'll add that to the open follow-up question list.
Okay, guys. So I think we're out of the time. Thank you, Ryan. Thank you, everybody.